Well, after about 36 hours on site in Las Vegas, my and Alex's CES adventure is just about at its end. But I do have to say that we saw some amazing stuff here in Las Vegas at CES. Some really exciting demos, some very interesting real-time applications, some fascinating hardware as well, and lots of excitement and bustle and hustle from the CES show floor, which is everything it's made out to be and more, I'd have to say. So I'm joined here again by the aforementioned Alexander Battaglia. Alex?
Hey, yeah, we saw a lot at the CES already, and kind of on the last day, looked at some Nvidia stuff. And that's going to form a large bulk of this discussion here on today's Direct.
Yes.
And a lot to talk about there, along with a lot of other things that we saw on the show floor and in the booths and in the suites and in every place you can imagine. We were everywhere here, as much as we could for the time that we were. So a lot to talk about, right?
I think for Alex in particular, this was an absolute show-stopping show because there was so much excitement in PC gaming, in particular from Nvidia, who are obviously leading the way in a lot of very exciting technologies. But today I think we really want to talk about some of the demos and some of the things that really caught our eye that we could actually see in person.
Yeah, right.
So just earlier today, we saw a series of, I think, truly incredible Nvidia demos. Some games on show, but also some amazing technical accomplishments with stuff that is maybe generously a bit of a preview of what we might be seeing in the future. So Alex, why don't you walk us through this first demo, which was concentrated on this new Nvidia Mega Geometry technology?
Yeah, just as a little preface before I describe it initially, we were in a room with a lot of these demos running. And in comparison, for example, we just had a video talking about AMD FSR4, or the research project. And that I said it was a contextless demo. The demos that we saw here at Nvidia in this very large room with a whole bunch of them, I'm talking about 20 plus different demos, the most amount of tech stuff and technical features that I've ever seen ever at one moment. And these were not contextless at all. Each station had one or two engineers and or artists talking about their work. And there were industry giants in there. Chris Wyman was there. You also had Aaron Lafone. There was John Spitzer was there. Like huge Nvidia superstars that kind of worked on a lot of the core tech in really big ways that we've seen over the years, like really big breakthroughs on the research side. And they were just there to talk with us. And I had really great conversations with all of them, which enlightened each, and there was a lot of other people there too, whose names I'm just currently forgetting at the moment, but basically each demo was enlightened by questions being answered and just general chit chat about what we're seeing on screen. Because a lot comes up, and that's how I got all the info I could, not just seeing it, but also talking with people, which I think context is important always to giving these demos, right?
Yeah, they provided some really incredible context, and I have to say, there's a bit of a fangirl moment sitting in a room with probably the highest concentration of graphics engineers, like top-end graphics engineers, this side of the Nvidia headquarters, I'd have to imagine, at any given time.
It was awesome.
So it was really exciting, and there was a lot of really, really compelling demos. So why don't we start off with this Mega Geometry demo, which depicted this great, giant, animated, flying, kind of vaguely Asiatic dragon thing flying through some environment here. Yeah. Pretty compelling stuff.
And like a rock precipice with a guy wearing like an Asiatic hat. I don't know the name of the hat, actually. I'm sorry.
Kind of a straw.
Yeah, it's kind of like, you know, like if you've ever seen Raiden, like both from the John Carpenter film, Big Trouble in Little China, as well as the character himself and the mythological character, kind of like that kind of style hat, straw hat. Really beautiful demo. And so Mega Geometry in general, based upon what we saw here and what we're looking at on screen right here, is NVIDIA's way to try and solve a very important issue in ray tracing APIs and in ray tracing in general. And basically, ray tracing has the problem where there is a large acceleration structure for every bit of geometry on screen, and the things that are easy to build this acceleration structure for are those static things that aren't going to be moving and aren't going to be changing. But the things that are moving, like dynamic geometry and characters, things where the geometry deforms, those are expensive. But usually a lot of stuff on screen isn't animating at once. It's usually just characters and stuff like that. Maybe you'd see vegetation moving and such. But a hidden cost to every game that has ray tracing is the fact that modern games use level of detail. And well, level of detail has been around for a long time, but they're exclusive. Almost every object in the game world will have multiple levels of LOD, like LOD 0 all the way out to 5, 6, 7, or even 10. And that every single time a new LOD is loaded in, and if the geometric representation as well in the ray tracing acceleration structure is changed at the same time, each time one of those changes occurs, an entire rebuild of the acceleration structure at that point has to occur for that thing. And that is an expensive process in itself, costs on the GPU side, as well as there's a CPU-related cost. This is especially important now when we now have nanite, or even more complex like mesh shading and stuff like that, because the potential of level of detail changing constantly is always there. And as you move through a world with nanite, every single frame could have just hundreds, thousands of LOD changes, and it becomes completely impractical to start doing full rebuilds on the GPU and the CPU related costs of all these things as well. Mm-hmm. It is just unfeasible. That's why nanite relies on, when you do hardware ray tracing, it relies on what is called the fallback mesh, a lower percentage representation of the real world nanite mesh. And yeah, there's a lot in there, but basically this is their way to try and solve it for RTX GPUs. And it requires a new API, essentially, running through NV API. And what it does is it is a streaming scheme and a new way to, it's actually not too different from what I heard from DXR 1.0, but it is enough different at a point to allow for the quick streaming in of clusters, clusters of geometry, at any 1 second, all the time, without doing full, super expensive rebuilds. And it allows for a lot of crazy stuff that we're seeing on this dragon here, as well as on the other character kind of lifting their arms up to them. This is a demo of something that has never been done in real time before. It is a fully tessellated, deformed mesh animating at a 1 or even smaller triangle per pixel ratio of this dragon. And another thing to really stress about this, there are diffuse textures on it, but there are no normal maps on this dragon at all. There are no normal maps. This is doing something that is really ridiculous. It is no normal maps, so all the detail you're getting from here on the mesh itself is all coming from real geometric detail that is changing every 1 second. And when you flip over to the wireframe mode, you can really get a sense of that, about how much geometry is just on these things. It is white noise. It's basically white noise when you look at it. There's so much geometry no matter what you do. And there were, on the demo, they could control the level of tessellation. They can control so much actually in the demo. They were turning off turning off the tessellation just to the base mesh essentially, because the tessellation is actually done via like a height map kind of thing. Mm-hmm. And it led to unparalleled levels of geometric detail. And another part of this that this is doing too is because they have such really amazing cost per triangle now, and also a reduced cost in other aspects, like the size on disk is smaller as a result of that. They could do, for the first time also that we've seen in a while, this was also primary rays were being path traced. Sorry, this is another technical detail where games that have been fully ray traced so far that we've talked about on the channel, things like Alan Wake 2, Cyberpunk, Indiana Jones, they do the lighting in a ray traced way, where first hit lighting and as well as subsequent bounces are done via ray tracing, but the actual view matrix, looking into the world, deciding which geometry is on screen and which one is not, that is actually still done primarily through rasterization. And here we were actually looking at primary rays being traced. So that means they didn't do it for the demo, but crazy stuff could be done like that way. Like they could distort the screen. They could do crazy FOVs. They could do a lot of things like ray traced or path trace scopes, where you would look into a scope and the scene would bend behind it. You know, like tracing primary rays, we haven't seen it in any of the full ray traced AAA games. The only time we saw it actually has been in stuff like Quake 2 RTX and Minecraft RTX, where they did do some of those things. But in any of the full RT games yet, we haven't seen that yet. So this demo was doing a way of showing geometry that has never been done in real time in a game, and it was using like open subdiv as well to do it. Like, this thing was nuts. And they were showing stuff like on the one character's hat. They would get right into it and show like, yeah, this isn't like, we don't even need to do alpha cutouts anymore. This is just all geometry that is subdividing in real time as you get closer. And you could probably see my face. I'm going nuts. This demo was insane. And I think that like my main takeaway here is that we're finally, there's a lot in these demos that were constantly mind-blowing, but this one is going to be also a huge performance win for the future. This is an API difference. It is currently limited to NV API, but this is going to be something that NVIDIA is going to be working with Microsoft to get it as a standardization of some sort. And we'll see how the other IHVs decide to roll with this type of technology, because they're all going to probably come up with their own implementation, just like there's differences in implementations of ray tracing between Intel and AMD. And this is a huge deal. Like, they have their own. This was shown in a custom render right here, but the principle applies as well. It could easily be applied to Nanite. It could be applied. It's going to be applied to Alan Wake 2. They're going to use it to like massively accelerate the foliage tracing in that game, which is all done via skin geometry. So it's going to lead to speed-ups. Now, this does run across all RTX, but it doesn't mean that this scene would run across all RTX cards quickly, because there's so much geometry to trace against here. There's a reason why Blackwell ran it well.
Right.
But this demo was insane. I don't know. What did you think of it, Oliver?
I mean, I thought it was just incredible. It reminded me of like what you see often in CG, where they basically say, "Oh yeah, we're rendering this character on screen," and we're eschewing the use of normal maps, as you often see nowadays in high-end path trace CG. But the idea that you would actually achieve that within a game render, with all the limits of having to achieve that in real time, and have that level of geometry and have that level of subdivisibility to the image, I just thought it was just astounding looking. And I mean, the lighting and everything they had set up, I mean, it just looked like a next level render of something that I've never really seen before in a title. And it's something that wasn't even on my radar in terms of something that would be achieved kind of in real time. It's just super impressive. I think it even wrinkles in one of the characters' faces. It's just all stuff that blows you away, because you kind of zoom in and you zoom out, and you never really get that impression that there's a level of detail that you're not reaching within that real-time render. So that was super impressive.
Yeah, and it's really the next step. And this is already going to be coming to games very soon with Alan Wake 2. But this demo here, with like the path traced primary rays and whatnot, this is like the kind of showing of the entire proof of concept of what it can be. And a couple of the demos were like that, right? They're saying like, this is the nth degree goal. A AAA game may not be doing this because there's disk space considerations for a lot of stuff. You don't just want, you also have real-time performance considerations. Not everyone's running on RTX 5090, et cetera. So this is like the future of rendering, but it's running in real time, and it's this way it's going to be soon.
Yeah. So I think that was like really the standout demo that I know that as soon as we walked into that room, that Alex made a beeline for that demo. He ran to it. He was drawn to it like a moth to a flame. But there were some other demos, some of which showcased some technologies that were teased at Jensen Huang's keynote address, which me and Alex were actually in attendance for, which had all the atmosphere of a rock concert and all the intrigue of a very interesting technical white paper, I'd have to say.
Yeah, it was nice.
It was very, very nice. But we had this Neural Materials demo, which is something that was teased in the Blackwell announcement from Jensen. But I think this is very interesting. Basically, you have this a neural network-based technique to depict the characteristics of certain materials that might be very, very challenging to depict using kind of conventional techniques. That's basically the gist here, Alex.
Yeah, basically the whole thing is we use simplified models for different types of materials in games. They're BRDFs or BSDFs, and they're limited to like diffuse, very specular, glossy. There's sometimes anisotropic materials. That's pretty rare though. There's maybe like a specific one for hair, maybe there's one for eyes, etc. But there's limits usually to those, and to keep the complexity down so that the shader, you're not spending all this time shading. They are limited in their length for games. The complexity is brought down purposefully. For offline renders, the size of a shader actually could be incredibly large, much longer, and it's just not practical for games. So what this does is this is training models for very specific materials and material types with many layers of different types of responses to light within the material itself, like many different layers. Like maybe the first layer is like a really direct specular reflection, but then it like diffuses beneath the surface, and maybe it spreads out. You'll see this with like car paints. You'll see this with here they show off like a silk material where there's multiple directions of light scattering through and around it.
Yeah, it just has like this incredibly complex lighting response that you almost never see in a kind of material in an actual shipping video game.
No, it's impossible.
Yeah.
I don't think that this has ever been done before. And this is essentially bridging the gap to essentially real time of bringing offline rendered material quality to real time. And you'll see this there's like the patina of like ceramics will be different. There'll be dust, there'll be smudges. And then below that, you'll see some other stuff. It just like goes, there's like something like 15 layers deep that is kind of, I wouldn't say compressed down into this neural texture, but it's trying to represent it on a certain level. And they would flip on and off in between the demo to show some things. And there's a couple areas that I would love to highlight. There's these gems on the front of this thing where when they turn it on and off, you can see like such an incredible difference in there's like a star-crossed pattern on the gem itself and like multiple layers of specularity. And then below that, you see like the substructure. There's so many different layers to this material in real life, you'd be like bouncing a ray through that like infinitely to try and get these larger responses. But here it's like the material giving you that,
Right.
And this was all a path trace demo too. So that tells you a lot about it, but it really just made the materials look a lot better. And when you flip on and back and forth, you can see, I mean, really, if you saw this in a game, you'd be hard pressed to like actually think it was real time. It was another ridiculous demo. And there's a lot of technicalities to this. So one of the things that Jensen also mentioned, I think as well, like this demo here was also using neural texture compression as well too. And it's just neural texture compression. And this allowed, so the texture is not only the material is not only a lot faster than it would be if it was using like the offline quality ones, but it's also saving space versus regular like block compression textures that you would see in modern games. It is actually a lot smaller than them while being higher quality. And this is kind of like the DLSS advantage that we've seen in games before, where DLSS can look better than native. This is actually a lot more hardcore than DLSS. I'd say this looks a lot better than the native material response while being lighter in terms of memory. Obviously, there's a trade-off though in processing time because you're using machine learning to do this up in real time. There's this cost of running it in real time on the tensor cores. So there's a trade-off there. You're spending a bit more frame time to do this, but it is a lot cheaper than it would be if it was an offline material, which just wouldn't run actually. And also that like the memory savings would be a big deal too. This was an insane demo.
I mean, Alex obviously has gone into enormous detail here. All I'll say is that like when I was looking at this demo, both in Jensen's keynote and in person here, I was just so blown away by it. Like usually in a game, when you look at a material, you can kind of identify like, oh, that's kind of this is how it's done, here's how it's simplified. You can kind of visually tell, oh yeah, that's a game material. And to me, the idea of this being represented in a video game, all of a sudden it has to, I have to recalibrate my expectations about what materials can look like in video games versus offline rendering. It's certainly extremely impressive.
Yeah, and both of these images that we're seeing here are both path traced. You have to just remind yourself of that.
Right.
They're both path traced, but one can represent the materials better, and it leads to just like the path tracing looking. It's the same path tracing. The material response, though, is just much more accurately modeled. So the complexity of ray tracing here is the same. We're just it's a whole nother level, and now this is brought about by neural shading, and here there's a collaboration with Microsoft to bring this to DXR, and that's a part of it. There's a Microsoft blog on this. I forget the name of this API. It has a hilarious name. I forget the exact name of it, but basically this is going to be added into normal DirectX, and it's going to allow for the usage of tensor cores within a normal compute shader, and you can use it at the same time. Earlier, before that, tensor cores were blocked off essentially from anything other than really, CUDA usage or DLSS usage.
Yeah,
right?
exactly. Yeah. But that's not the only extremely exciting implementation of a neural rendering feature in the NVIDIA showcase. And I just wanted to introduce this new demo with a question from some guy person. He asks, is it just me, or do NVIDIA's neural faces and that text animation feature look absolutely dreadful? Well, some guy person, we aren't going to talk about the text animation feature today, but we can talk about NVIDIA's neural faces, because we actually saw a couple of demos that featured the neural face technology, and I think that our impressions were broadly a little bit more positive than what some guy person is implying here.
Yeah, so there's a bit of context to this. The demo, the change that you saw on the stage, as well as in any of the press material, was a version of it that we didn't see. We saw one that they were literally working on up until 5 minutes before we came and looked at the demo. They literally just had finished compiling the exe or whatever to actually do it, because they were literally working on it right before. And now this is not an actual feature that is going to be shipped in games, because this is still work in progress, and this is the future of what they want to try and do. And what we saw on this model right here, specifically, with the thing that they showed in the original demo on stage with Jensen, as well as in any of the press materials that might have come out at this point, I will say it was almost like a Yazify filter. It did look like the hire the gamers please filter kind of thing. Now, this joke you've heard before of people were
Nintendo hire this man.
Yeah, the total I used AI to fix this game kind of thing. And it did give off that vibe totally. There was a visible change in almost facial structure of the person. It almost looked like it was adding makeup to them. It's a very specific thing. But this one right here, I would say specifically the first one, it was much more kept after the update we saw. We saw the updated version of it, and as it flips back and forth, you can totally see that the exact style of the face is actually extremely similar. Mm-hmm. It is not changing style on face, actually, like you saw in the original demo. So I think that was just an earlier version. And actually here, when we flip back and forth between it, what you have to think about this here is the entire scene this is using Unreal Engine 5 here. Yeah. And it's using the path tracing version of it. But when they put on the face, almost like a deep fake, it is not doing any rendering, traditional rendering at all. The entire face, including the shadows, the shading, the animation movement, is all being done via a machine learning rendering. And that is something we haven't really seen at all before, ever, actually, in real time in games. So this is completely and wholly unique. Some things when you switch back and forth, like I said, it's not really Yazify filter. It's really not that. And a good way to show that is that you can actually see that the subsurface scattering changes between the views. It is actually doing things to improve the surface shading model of the character. It is going to be changing the way the eyes respond to light. It's going to be doing a lot of these things. Now, the reason why I say this is still super work in progress, and I'm actually kind of happy they showed it off like this, because they're realizing we need we want to have artists to have more control over this. We want to make sure that it is actually representing the base mesh, like the perfect mesh of the actress or actor who it's modeled after. That's why they say it's work in progress. And they, for example, they purposely didn't move the camera in the scene to certain angles because they said, like, we know this isn't perfect yet. Like, you could technically see a seam on one side of the head where the face is superimposed.
Right.
And they didn't want to show that, like, so, yeah, I thought this demo specifically looked really, really great. Then we also saw like the interactive AI demo too, where they used the same thing. I think a different actress there though, whoever was scanned. Now this one shows a little bit more,
more significant change.
More significant change between the face. But I would say there was a level of naturalism though in the movement of when she was talking to you that I appreciated. And yeah, that's one thing they are keenly aware. Like they asked us, like, what do you think? I was asked multiple times, like, what do you think of this type of demo? And I was saying, like, what I would like to see is I like the proof of concept, but I don't think it should radically change the facial structure of a person. It should be kept within artist's intent. And, it should only be a positive thing to bring us closer to ground truth. And that's how they saw it too. And they see this as a heavily work in progress thing. And they don't want to have it be like the ugly, AI generated stuff you can find on the web. They want it to be good. So that's the way I kind of look at this. They're showing us the future in a work in progress form.
Yeah, I did actually find this a little bit interesting because in high-end CG productions, they've recently taken to using similar techniques, often termed somewhat pejoratively, but I'll use it in neutral context here as deep faking, where basically you have an extremely high-end, extremely expressive, fully CG face, like in the Star Wars films, or for instance, in the recent Harrison Ford Indiana Jones movie, not the game, but the movie, where they need to basically depict someone, in many cases, who is quite a bit older, perhaps, or who has passed away, and they need to depict them with basically a CG character, but it needs to look extremely close to the original likeness because people have a very firm idea of how that person looks, and people are also extremely finely attuned to the physicality of the human face. And they actually find that even with this very high-end CG, that when they apply this deep faking process to the face, they can actually just get that little bit further, that little bit closer to reality, and have people accept that face as a real-life face instead of something that is like, that's just a little bit off, like with Tarkin in Rogue One, for instance, where it's just a little bit off, it's just that tiniest bit off, and you can kind of tell that it's not a genuine face. And in this case, you're getting that level of naturalism, I think, in the face. There is, some amount to which you could say, that's a Yassify filter. I think that was certainly somewhat more true for the other demo and not for the first one. But in general, it's a more natural looking face. It's a less gamey looking face. And I think ultimately, like it does look quite pleasing there. So I think this brings us a little bit closer to that ideal of having very realistic human facial portrayals. Now, obviously, this is very much a work in progress. And like you said, the Yassify element of it probably does need to be tuned to some degree. And there probably does need to be some level of artist control that is quite consistent there. But I thought it was quite a compelling demo. But Alex, that wasn't the only element of this demo that caught your particular attention. There's also the hair rendering in this demo.
Right.
So explain that to me.
This one is interesting because ray tracing hair is really hard. The modern hair techniques in games, if they use splines, usually not the entire head is done with splines, but like at a certain distance, it'll LOD change to cards. It'll be mixed cards and splines. Splines are tiny little strands of geometry. Sometimes these strands are not rendered with like the usual hardware on a GPU, but they're done with a compute shader. But the whole point is trying to trace against tons of tiny, thin bits of geometry.
It's a nightmare.
It's a nightmare, and like some of the ways they would try and cheat that would be to extrude the length of the triangle. But then it becomes like increasingly ridiculous to trace against then. Like there's a whole lot of reasons why tracing tiny, thin little pieces of geometry is ridiculous. So their solution here is a new primitive to ray trace against. So there's a lot of things you can ray trace against. You can ray trace against voxels, you can ray trace against triangles. But another thing you can ray trace against is like spheres, and they're calling these Lanczos spheres. Basically, they're like little connected spheres and hemispheres at the end of like long lines. That's like a way to describe them. And they're much more simple to trace against. They're really fast, apparently. And this is a new thing to RTX, and it allows for much more efficient visualizing of the hair, as well as much quicker trace time against the hair. So in this demo, they said the art wasn't finished for the demo for the hair, but it used the new technique to render the hair, which gave, it would give you things like perfect shadows from hair. It would also give you like, just like way better lighting in the hair itself too, because it's now being path traced against instead of being done through typical rasterization lighting or something like that. And that's usually a disconnect in games, because sometimes there's been games with like path tracing, but not the hair. It's not path traced to the same level or whatever. So this is
like in Indie.
Like in Indie, like I pointed out back in Indie. And I think Indie, based upon the press release, is getting this RTX hair. Yeah, I think that was a thing they showed in the press release. So this should be coming to a game near us soon enough. But right now, I believe, it's just a new way to do hair and a new way to do ray tracing. And it's not just limited to hair, the style of tracing. It could be technically applied to different other types of, I wouldn't call them materials, but different like things that have volume and whatnot. Like there was hints that it could be used for a lot of other things than just hair, which is awesome. So this is another thing that'll make ray tracing faster and be applied to more objects.
Okay. Well, lastly, I think in the realm of demos that defy comprehension and truly are extremely impressive, there was one last demo here that showcased, I think, Mega Geometry as well as ReStir path tracing. Is that correct?
Yes. So this demo was another UE5 demo where they made the entire thing here with, what were they using? Yeah, they were using ReStir, path tracing, as well as the Mega Geometry. And what they were doing in this demo was trying to show off how Mega Geometry would apply to Unreal Engine 5. And the thing is, like I described earlier, there's the proxy fallback mesh with Unreal Engine 5 when you turn on hardware Lumen. And so the ray trace scene is a much simplified version. So you can't actually get direct shadowed ray tracing with it because the shadows are totally misaligned with the geometry. If you look in reflections, you'll see that they're not lined up perfectly. They are very simplified, and it can even lead to inaccuracies in indirect lighting as well too. This is a path trace demo, so that means the geometry has to line up perfectly with it. Now, there's a lot of insane stuff here. Okay, so they show off very simple things too, like, oh yeah, now we're getting, with path tracing on and the ray traced shadows, we're getting like the perfect shadows from everything, adding a ton of extra detail, right? Like they're looking at these vines on the wall, tons of extra detail in the shadows there. I asked another question about this demo, since it is using Mega Geometry. Another way we kind of simplify things in games, like in real world, everything's like three-dimensional, right? But for, stuff like, whatever. But for vegetation in games, they use alpha cutouts where it's like a triangle or a quad, and then there's a texture dictating which parts are transparent or not. That's expensive to trace against, but with Mega Geometry, you actually don't need to fall back to that level of simplification. So one thing this demo also had is all of the leaves are all done through real geometry. They are not alpha cutout cards, because now Mega Geometry allows them to get that level of detail while tracing and support it with the amount of triangles it has, as well as just trace against it efficiently, even if it moves and changes with each second or with each frame, essentially. And so that leads to unparalleled levels of, density of lighting information, density of stuff when you get up close. It looked incredible. And they also showed off after this a couple of other phenomena, like obviously they looked up close at geometry, turning it on and off and stuff and whatnot like that. But they also went over to these side galleries where they had perfect mirrors aligned. And this was using a ReStir PT. And they would switch on and off here between hardware lumen, lumen cache for the reflections versus using the ReStir PTE path. And there you would essentially see like extreme differences both in the quality of the geometry and the way the lighting looked in any of the reflections. It was night and day. So like if a game actually did have somewhat more perfect mirrors, it would lead to really intense differences. They also showed off like the differences of indirect lighting on these leaves in this corner over here, where there's a limit to the amount of detail in screen space that Lumen can achieve.
Right.
And it just actually did look like kind of generationally different when they would quick, it just allowed for just such a greater capturing of lighting detail on a small scale because actual geometry was being represented and not simplified over. This is another demo where it just goes to show the future of how this thing could be. I don't know how reasonable it is for a game to ship currently with, I think the size of the demo was
80 gigs?
Yeah, it was 80 gigs, and it was not using neural texture compression, which would, I think they said it would reduce it by like a very severe factor. It would be a much smaller demo because a lot of the demo was actually, they were spending a lot on the texture sizes and whatnot like that. So like this is a very promising thing, and it's already it's going to be in the NV RTX branch, and I really hope to see this in games because this is like Lumen's good, but it's great if you can scale higher than Lumen and also start representing other types of effects that if you have the real triangles being traced against of the primary view scene. Yeah.
I think that marks the end of our kind of real highlight, mind-blowing graphics rendering demos from NVIDIA here. And we should probably move on to some of the games and some of the implementations of technologies that we might actually see in the more kind of short to medium term future here.
Right.
One thing that really did impress me, and the next thing that we looked at, was this demo of Black State, which we've already obviously covered on the channel before. It's an extremely impressive title that also happens to run at a fairly ridiculous performance level on Blackwell GPUs, also on Ada GPUs, also probably on RTX 3000 GPUs.
Yeah,
it's truly remarkable.
It probably
demo.
scales low. It looked like an extremely optimized game, and it was running Unreal Engine 5.4, but was not using Lumen, was not using Nanite. They elected to not use them. They're using instead ray reconstruction here, I believe, as well as like hardware ray tracing. And they've said they're doing a lot of stuff custom that is actually very diverged in a lot of rendering ways from standard Unreal Engine 5.4. And that kind of gives the demo its like amazing things. They were like really focused on having no stutters, which is a typical Unreal Engine issue, immaculate kind of like geometric detail without nanite, immaculate, I would kind of say, materials. I'm not talking about like neural rendered materials. That's obviously another level. But for a current AAA game, kind of quality materials, extremely high up there, like really clean. It was running in like DLSS quality mode, 4K if I recall.
Yeah.
And even without like the normal frame gen on, it was already like in the hundreds FPS, right? It was like really high. And then they kept turning on levels of frame gen and it just kept getting more and more ridiculous.
Yeah.
Yeah.
I think by the end they were like just faintly shy of 400 FPS.
Yeah. I think it was DLSS performance mode with the quad.
Yeah.
With the quad
frame gen, yeah.
Which was like 400 FPS. The monitor couldn't even display that, but it was just ridiculous. And the demo also, there's a lot of other things to praise about this. Like there's a lot of physical effects, like a lot of physical objects. The effects work was ridiculous. They showed this boss fight with this like, I don't know, it looks like something almost like a mix between Doom Eternal and like, I have no idea what's going on. This art style is crazy.
Kind of like some Kojima stuff.
Yeah, some sort of Kojima stuff. Like this guy looks nuts, and he's like shooting out these like wave distortion effects, refraction, and also all of the GPU particles in the demo were reflected in the ray trace reflections, which is definitely not a thing you get in standard UE at all. Not. They added that in. So these are like custom reflections as well too, and it was just running like so ridiculously well while looking smooth as heck. And like they also showed off some other wicked stuff like when you shoot enemies, like they dismember incredibly.
Oh yeah. Totally.
Like I didn't expect that, but he was like, yeah, I'm just gonna like shoot off this guy's leg.
Yeah.
And there's a lot to be said about this. Like these guys at Motion Blur Studios, they're from Turkey, and they have like a great adherence to really good technical art, smoothness, and attention to detail. Like every texture you go up to, every little bit of geometry, not using nanite, mind you, you get up really close, you can see like variations in material. You can see like tons of just variance in just how the little bits of geometry look across the scene. They were really intent on showing that off. And the game, they wanted it so that when you get close to objects, you're not like seeing textures break down.
Right.
And that's all throughout the demo, basically. And the third-person camera at the distance it has, everything just always looks high res. It looks incredible.
Yeah, I'd say like a lot of these details, like this kind of plastic lining here,
Yeah.
just like so fine. And oh my God, look at that flaky paint there.
Yeah.
I mean, it just really does look ridiculous. They showed us a new area as well as I think an area that they might have demoed off
To John and Rich, yeah.
To John and Rich,
Yeah. And the new area was like the boss fight area. And they show
really impressive.
other really cool things like that, like when you go in between rooms, they switch out the rooms and it like portals to the another area. And you can go back and forth between these like portal rooms. And they really wanted to emphasize like people, when they saw this trailer originally, they thought it was like a fake game. Like we've seen fake games, like what was that State game? I don't know. Do you remember? It was like they got like they tried to release it and it was like some sort of BS demo on Steam or whatever. What was it called? Like it wasn't State of Decay. It was like Death State or I don't know. Okay. Write a comment below this web zone if you know what I'm talking about. Yeah, it's not a fake game. It's super real. They were
real.
Yeah, they were playing it right in front of us and it just looked ridiculous the entire time. This is one that I really want to cover on the channel when it comes out because they're focusing first just on a PC version. They wouldn't comment about consoles and they just wanted to make sure that the PC version was super high quality and running really well across a variety of hardware. They really wanted to emphasize the fact that they want a game that runs well on a lot of hardware. So,
yeah, I thought it was really compelling too because they had the game on a 240 hertz monitor there, but they were actually hitting frame rates in excess of like 50% higher, higher than that. So it's like this is a game that looks top notch. It's like one of the best looking games I've ever seen in person for sure.
Yeah.
The kinds of stuff they're doing with Unreal Engine. It's just really intense. I've never seen anything like it, and it looks incredible. And it's running at such a high performance level on new RTX Blackwell GPUs that even the very highest end displays that currently exist don't really capture its majesty. Like it is just such an incredibly compelling demo, and it really shows off the kind of incredible performance that you can have with MFR or with MFG rather, which is a really compelling technology when you hit these super high frame rates, I think.
Yeah, definitely.
But moving on from the novel to the well-worn.
Yeah.
We're covering Alan Wake again on this channel.
Again.
Some limited form here. Because we had a very interesting DLSS ray reconstruction demo featuring Alan Wake 2. So why don't you take it away, Alex?
This one was the old model, the CNN model on the left, running versus on the right, the new Transformer model. And ray reconstruction, as Rich talked about it in his video and our first impressions, and obviously we would love to do more dedicated, like we actually look at it in a big way in a video. But in the meantime, we just saw it here. And much like Rich, we saw like elevated quality across the board. No matter what you looked at in Alan Wake, like they showed off this table here, really a lot better surface detail on the table, better reflection of the actual normals there. If you look at like the spinning fan on the ceiling as well too, ray reconstruction is way better than standard denoisers, even in the old 3.5 CNN version of it. It was just way better in a lot of ways, but it had issues. But Alan Wake 2 was one of the games that actually had less issues in Alan Wake 2 than it had in Cyberpunk. It was already looking pretty good, actually.
It actually looked like, I mean, from a normal viewing distance, I wasn't really identifying any issues with it, whereas in Cyberpunk, that wasn't really the case. Like, you could definitely see, like, oh, there are some issues with the faces, and when colors are not quite right, when you get indirectly lit areas, it doesn't look so great, and you get that kind of, like, odd warping and warbling to certain edges.
Yeah.
With Alan Wake, it looked pretty fantastic, but here it just, like, looks even more kind of next-level stuff.
Yeah, and, you know, there's a lot of other things that'll be, much like we saw in Cyberpunk there. But here, you know, like, side-by-sides, it's just, like, a lot less ghosting, just more detail, better reflections, etc. It was across the board. And this is one that I think there's probably in all due time, if the hardware's there, if I have the hardware, it would be something that I would cover in like a dedicated video at some point. But there's so much going on that we'll see if and when that happens,
Yeah. It was certainly very impressive. Even on some things that weren't lacking at all in Alan Wake 2's ray reconstruction implementation, like the quality, the fidelity, the sharpness of the ray traced reflections. We even did note, like, they're a little bit sharper, they're a little bit cleaner, the lines are a little bit more finely detailed.
Yeah.
In the new DLSS 4 version. So I thought that was really cool.
Yeah, last thing to mention here is that this demo was not using the fully updated version of Alan Wake 2 that's going to be coming out in some point in the near future, which will add ray reconstruction as well as multi-frame gen. This did not have like the enhancements to ray tracing, as well as it did not have Mega Geometry, because those are other things that are going to be added to Alan Wake 2. Oh my gosh, they are doing so much stuff. This is ridiculous. I have no idea how we cover this.
On top of like already what's like one of the best looking games in the market, to pull this off as well, it's certainly an extremely impressive accomplishment. But moving on from the world of high-end rendering here, onto the world of esports, I suppose.
Which we are such, we're so into esports at DF.
We're such big esports pros. We're such big esports pros. Catch me in a round of Counter-Strike.
That's Will.
Yeah, that's Will. No, Will is a bit of an esports pro in his own right. But we have the finals, which actually was not a demonstration staging area for any new crazy mega geometry features, any kind of neural rendering craziness. Instead, it was a bit of a testing site for NVIDIA Reflex and NVIDIA Reflex 2.
Right.
Which is a very interesting technology, kind of extrapolative almost in nature. So why don't you explain what we saw with the finals?
Yeah, sure. This one is basically, I think this is just the training area of the game.
Yeah.
And it was very much so it was showing off a very interesting thing. It was running at like 90 or 100 FPS, or even a little bit lower, like 80s at times too. So I don't know what the hardware was exactly and the settings that it was at that. I don't actually know. It could have been like a 5K monitor. I wasn't looking at that.
Yeah.
But that was the gist. And you could, with a single keystroke, switch between Reflex off, Reflex 1, and Reflex 2. Reflex off actually did feel noticeably weighty. Like, I actually did feel, it felt noticeably weighty. Then you turned on Reflex 1 and it felt like immediately better. That was a really apparent thing.
I think it was going from like about 50, 45 milliseconds of latency there down to like 20 milliseconds or so as measured.
Really big difference. Like, it was a huge difference actually. And so that was noticeable. Now Reflex 2, I would say less noticeable because we're talking about like,
one frame.
It's one frame at like 100-ish FPS or whatever, so it's like 10 millisecond difference between the potential latency numbers. So I couldn't, felt a little bit more immediate, but it was totally within the realm of maybe placebo perception.
Yeah.
But the whole deal that makes Reflex 2 interesting, and we're gonna see how people feel about it when they get it on their hands. It will definitely probably feel mostly more immediate to most people. Yeah. But it's also like playing with your perception to do this. It's basically like kind of like, what do they call it? Like space warp?
Space warp. It's basically like the kind of warping that you get when you have 60 hertz content on a 120 hertz display for PSVR 1 and PSVR 2.
Right.
And I think other headsets do this as well.
They all have specific names for them.
Yeah. Where basically like they take this 2D image and they kind of warp it to align with your current position in the VR space, your current movement and velocity. They kind of try to do that. It's like a space-time warp or something.
Yeah, like that. There's a phrase for it that I just can't at this late hour after having like buzzed through all this
Very
stuff
late.
today. But like that warping, they have to like cover the edges of the screen. They have to cover all the disoccluded stuff, as he was saying next to us. And we were just trying to like look for it. And like the immediate impression was like, you don't really see it.
You don't really see it.
No. And like if you were to if you were to play the game in a way that you wouldn't play an esport title, I would say like where you go like this up to the screen and then you look at like text at a distance, or maybe you look at the corners of the screen where you could see like objects doubling for a little bit at like the very edge of the screen. But I don't think that's actually how people play competitive FPSs.
Yeah.
So I think this will actually be something that most people could potentially turn on and just say like, yeah, I'll leave that on.
Yeah, Alex and I were really doing some of the most hardcore pixel peeping that I can certainly remember in my time at Digital Foundry, because we were pushing our faces right up against like the barrel of the gun and seeing how its movement differed and seeing how the trails of artifacts differed between Reflex 1 and Reflex 2, which was complicated a little bit by the fact that the finals makes very, very heavy use of screen space effects, screen space reflections, which kind of get tied up and all that stuff. So
it's already disoccluding. It already has disocclusion issues anyways, right? So
yeah. We were able to see just a tiny bit of additional artifacting on that gun, almost like a kind of double image effect, but not quite, where like that very, very, very fast kind of generative fill is showing up in the image. But it was very minor and relative to the other kinds of image quality issues that we observed in the finals. Which I'm not trashing the finals. I'm just saying that there are issues inherent to the way that it's doing its lighting, for instance.
And another thing like that made this hard to see was that this wasn't like a G-Sync pulsar display, I don't believe, or something like that. I think it was. We were also seeing like persistence issues.
Yeah.
Like it was pretty. It was generic. I would just say it was like weirdly hard to see, and we didn't come into it expecting that. I think we were expecting to see more issues, right?
Yeah, I was personally expecting just to see like some greater amount of issue here, but like I don't know if this feature was offered in any game. I mean, it's kind of a take it or leave it feature, I suppose, if it's only going to improve latency by 1 frame. But I wouldn't mind leaving it on in just about any game because I don't honestly think I would ever really notice it unless I mean, granted, this is a first-person game. Third-person games could
be different.
More significant issues with disocclusion. If you're running this at like 30 FPS, maybe don't. I would have to advise you, especially if you're playing with very high sensitivities. Possibly that could also play into it, right? We weren't like going crazy with mouse sensitivity or anything like that.
Yeah, like I imagine if you did like a full 360 arc in like one, like I'm talking about like 6,000 DPI or something like that. Like anything, you'd probably find issues, but I don't think that's what this was about. I think it was like immediate mouse feel, but yeah.
Yeah. So but I think that closes out our NVIDIA demos today, or at least the ones that we want to talk about. Those were the ones that really blew us away from a rendering perspective in particular, or with some of these new technologies like DLSS 4, which are going to prove, I think, quite compelling in the near term. But we really wanted to just focus on those immediate mind-blowing kind of NVIDIA demos here, stuff that we can show you, but we'll talk more about NVIDIA hardware at a later date, I think. We'll talk about that in more depth later on. For now, we really just wanted to focus on the kinds of demos and experiences at CES that really caught our attention. And those were certainly up there with, I think, some of the absolute best game demos I've personally seen in a long, long time.
Yeah, this was literally some of the most impressive real-time rendering stuff I've ever seen in person. And that takes a lot to say that to me. Like I've seen a lot, and this was showing the immediate future as well as 5 years from now. And I can't even imagine what they'll show off that could look like next time around. It's like NVIDIA, man. Wow.
Yeah. But there were some other sights and sounds at CES outside of NVIDIA, if you can believe that. One such sight and sound that we did see is AMD. We did go to the AMD booth. We did see some interesting stuff at AMD. By now, we will have already published our video covering AMD's research project, aka FSR4. At least, quite possibly FSR4 there. But they actually had another interesting research project demo to show us.
Yeah.
So can you kind of explain what was going on there with some kind of interesting ray tracing, denoising?
Yeah.
Kind of weird thing.
Once again, now this is a lot of disclaimers here. This was a contextless demo. It wasn't really so readily described to me what I was looking at. It was just there and it was running, and it looked to be, we're just going to call it the denoising demo, but it looked to be running on presumably an RDNA 4 card.
Yeah.
And it looked like, I would consider it like a full RT implementation almost, where it looked like the direct lighting shadows as well as indirect lighting were handled via ray tracing. If you turned off denoising, which was possible in this demo, you could see that some stuff was actually more coherent
Right.
without it. So maybe, some things weren't fully,
Maybe not fully.
not full PT or whatever, but like more like a full RT implementation. And it looked to me, when you would look around the demo and turn off the denoising and then turn it back on, there was a couple things that told me I was looking at something very specific here. When you would turn it off, you would see that not only would it get noisier like you're used to when you turn off a denoiser, but it also looked significantly lower res. And if you looked at a static scene, like the shadows on the ground around these like little, what were they, cables on the ground, right? Like if you looked at them, even while sitting still, the shadow would be like slightly wobbly. And that's something like you would see in like a machine learned denoising, like a AI denoiser, someone might say. So this looked to me like a demo that was combining upscaling and denoising at the same time, much like ray reconstruction does. And given the artifacts that I saw on direct shadows, I almost want to say it is like machine learned, but I cannot know that. I unfortunately cannot know that. And this is me. I think there was a post by a GPU Open engineer a while back, or maybe most recently, about them having worked on this kind of thing. I'm extrapolating on information I do not have. So this is interesting for two reasons. One, it's good to see presumably AMD moving in the direction of applying machine learning to things that are very hard to solve in real time. It's also good to see more complex ray tracing running on RDNA 4, right? Like any of the full RT stuff has run extremely poorly on RDNA before. So this was like, I can't comment really on the performance. It's like 30-ish. I don't know, maybe a little bit above. I don't know. But so it looked good, and it was interesting to see. It wasn't like completely perfect. It was pretty unstable in some ways.
Yeah.
But,
it kind of looked unstable in like that kind of classic like Lumen style sometimes. I guess. It's
Yeah, and I'm reminded of like when I looked at Super Mario bit 64 with path tracing, where like Dario was applying like optics rather naively to the image, and optics is an AI denoiser, I'm pretty sure, right? So like it reminded me of that, and it's not a bad or a good thing, but it's just this is a research project apparently, so in the future there could be like a ray reconstruction type of technology from AMD. But I don't know.
I mean, for sure, it looked pretty low resolution internally, in addition to being extremely noisy with that ray tracing.
Yeah.
So it did kind of look like maybe something that might be venturing in that direction. Although the performance wasn't, it wasn't bad for what this is, but it also wasn't like outstanding.
It wasn't like looking at Cyberpunk, which runs really fast in comparison, right?
No, or something like Black State.
Black State, which was like super fast, right?
Insanity. But yeah, I would say that this is like the kind of thing that I'd love to see some direct feed capture of this possibly. I'd love to see a greater explanation of it. But like, again, the alleged FSR4, the great mysterious FSR4, it was just kind of lodged in AMD's booth with no one really to explain what it was, and even the hardware that it was running on, which is kind of in a state of limbo, a purgatory between announcement and non-announcement as we record this.
Who knows what's going to be happening when we publish this?
Right. It's a very good question there. But we also did see one other thing at AMD's booth, which I think was of some interest to me in particular, and of course to Alex, which was some new PC handhelds. Now, unfortunately, this was the only venue where we saw PC handhelds, which was something that was definitely on our list for this CES, but unfortunately they were in short supply apparently. But there was the Legion Go S, and I think also the updated Legion Go device, both running with AMD Z2 processors.
That sounds right.
Yeah, one of them was running with the next generation Z2 processor, but one was running with the old Rembrandt processor with Zen 3, I believe, and RDNA 2.
Sounds right.
Yeah. So what did you make of these? We've got lots of footage of Alex fondling and toying with these things. Experimenting with them. What did you make of them?
I thought the ergonomics were okay. The cheaper model did feel cheaper in the hands. I felt that was kind of obvious. Ergonomics were okay though. This was running Windows. This is not the Steam OS stuff that was also announced. We were not privy to that at the Lenovo booth, which we tried to go to, and it was just empty. And I don't know. We probably went.
They had a bunch of like private meeting rooms. I think. Yeah. If we had more time, maybe we would have scheduled.
Yeah, I think
something.
it required like an appointment.
Yeah.
But we didn't do that. But the funny thing is, they were showing Spider-Man Miles Morales on it. I'm sorry, it was running really poorly actually on both of them. It wasn't I don't know if it was a configuration issue. They were both set to DRS 30.
Right.
And one was also running FrameGen.
FrameGen, yeah.
Or AF. Right. Yeah, it was running FrameGen, FSR3 FrameGen. Yeah. And you know, frame rate would typically have been fine, but the big issue was that they were really stuttery.
Yeah.
Yeah, they were really stuttery. And you know, Miles Spider-Man is a CPU intensive game. Maybe it was the settings, maybe this was Windows, maybe this was driver, but they were stuttery and not very nice looking in that aspect.
Yeah, they were stuttering rather strangely, and then one of the units just kind of up and stopped working on you at some point. The controls just stopped responding.
Yeah, controls stopped responding. Yeah.
Yeah, that was a little bit awkward.
Also, remember when we turned it and then it went portrait mode on us?
Oh yeah, yeah. The gyroscope really kicked us there. Really irritating. But yeah, I would certainly echo Alex's comments when it comes to ergonomics. I think that both devices are a little bit thicker than something like a Steam Deck, and the grips are probably of a comparable overall size, such that kind of delta between the grip and the body of the device is a little bit less, so you don't get quite as much of that nice grip as you would in a Steam Deck, if that makes sense.
I know what you mean.
Yeah, and the grips themselves are kind of sloped a little bit more gently. It's a little bit of a different shape, but I actually appreciated the feel of both devices. I thought they both felt reasonably ergonomic. The full-size Go felt pretty good. The smaller size Go mostly felt pretty good, but it also had, you know, a little bit of a D-pad that wasn't 100% to my liking. It did feel a little bit cheap. They also had this weird little trackpad knob on the right-hand side.
I forgot about that.
Yeah, that did feel a little bit weird to me. It definitely felt like the kind of thing that is designed as a bit of a concession to Windows navigation. Because like we've seen with devices like the ROG Ally, I can personally attest to this, they really don't work so hot with Windows navigation. It's a big pain, but perhaps that track point does not really serve much of a purpose in typical actual gameplay. I also know that the Legion Go S is offered in a SteamOS variant as well, which I'm certainly looking forward to seeing at some point. Unfortunately, we're not able to see the SteamOS variant of the Legion Go S. But Valve actually had some news out of CES that I thought was kind of interesting, which is that basically they're going to launch that Legion Go S Steam edition or SteamOS edition in May. But for other handhelds, it sounds like in or around March 2025, they're going to start shipping versions of SteamOS for other Windows gaming handhelds, presumably including the ROG Ally, possibly including the earlier Legion Go devices.
Right.
Because that is something that they identified as a priority back in October. And I'm certainly all for it. Obviously, I love Bazite. And I think that the biggest hurdle to the success of these Windows gaming handhelds is actually, unfortunately, that Windows operating system.
Yep.
I think it's not very appropriate for handhelds, doesn't provide the kinds of features that you'd like in kind of gaming handhelds, doesn't provide the kind of smoothness of interface, doesn't provide the kind of relatively good suspend and resume functionality, you know, lots of different things that Valve has kind of worked through shader comp with Fossilize and all this stuff, and getting convenient driver updates. And I mean, there's a whole gigantic list there. So I think that's certainly very encouraging, but it also does make this Legion Go S device maybe a little bit less special, because it does seem like Valve is going to basically try to get their operating system out to many, many, many kinds of Windows devices here.
Yeah. I know.
But there were some other booths that did showcase some interesting stuff outside of the major hardware vendors, including another major hardware vendor who we'll get to in a moment. But coming from the OEMs, we did go to the Razer booth. Well, they had some interesting technologies here to show us.
Yeah, there was one of the first things they showed off, I don't know what they call it, cooling pads? What do they call those?
Hyper boost technology, I believe.
Yeah. Sorry, let me talk about this. I remember that. That's what it is. So basically, this is like all their laptops have been designed, and all laptops are basically designed ever since like since RTX 2000 or something like that series to be like TDP as well as like thermally limited. And if you base the design of the laptops is so much so that I think like the aluminum chassis allows it so that it can act almost as like a full-on heatsink itself.
Mm-hmm.
And if you put this cooling lap pad, what would you even call it? I don't know. Underneath it with like fans and whatnot, it'll cool the entire thing. And when connected to it, it'll essentially increase the TDP of the laptop, which will allow it to clock higher.
Yeah.
And you'll get improved performance on one of your older GPUs in one of these Razer laptops. So you can essentially buy this thing and increase the GPU performance of your system.
Yeah, I thought this was interesting. So basically they have these custom fit Hype Beast or Hyper Boost cooling pads. And I'm normally one to dismiss such technologies as being a little bit farcical because in reality, like we've seen a lot of these technologies for other laptops or for gaming consoles, and the reality is they don't do too much because it turns out plastic is an extremely effective insulator of heat.
Yeah.
But the difference with these Razer laptops is they are made out of aluminum, and if you've ever held one during a gaming session, you know they get extremely hot to the touch, very warm, and basically what's going on there is heat is moving away from certain components in the system, transferring to that chassis. It's basically serving as a heat sink. If you cool that chassis, therefore the theory goes, you might get increased cooling capacity, increased heating capacity rather for the system, and you might actually end up with a processor that runs cooler. Perhaps it throttles less, a GPU that throttles less, things like this. That would certainly be very compelling. And I actually know this partly from personal experience because I had a lot of Intel MacBook Pros. Now, Intel MacBook Pros had a certain habit, especially the 15-inch models with discrete graphics, of throttling. So my, notionally 2.0 or 2.2 gigahertz quad-core Intel MacBook Pros in 2016, 2017, 2018, you would run a big rendering workload on them in Final Cut, and they would throttle down real hard to like 1.2, 1.0 gigahertz. And one way to reliably ensure that behavior didn't happen was to simply put them over a large cooling fan. Now, I did not have something as fancy as this Hyperboost thing. I just had a large desk cooling fan that I would put under the laptop and that actually helped to cool the system and made it so it didn't throttle under those circumstances. So I am actually a complete believer in this. I actually think it probably does work pretty well. There was some weird framing though when we were shown it, like the idea is, well, there are new GPUs coming out, there's a new laptop coming out, so maybe you're feeling a little bit insecure about your old laptop, and so maybe you
this
get
is a FOMO device.
Cooling pad. But it did make sense to me that you might be able to, increase your TGP, as it's called.
TGP, sorry, my brain.
It's
late, everyone.
It's extremely late. Like up to 135 watts, maybe from 95 watts. I think that's something they said there. So that's certainly extremely, well, I wouldn't say extremely impressive. It was certainly interesting. It was very intriguing because I think it probably does actually work, unlike a lot of other kind of generic laptop cooling fans for you're just like typical Inspiron or whatnot.
Yeah.
There were a couple of other things that I think we can maybe touch on very briefly. They had a monitor stand chroma. If that kind of statement gets you excited, possibly that product could be for you.
Sure, but it was made of aluminum or aluminium.
They also had some ether light bars and a handheld dot chroma and various things.
Right, I forgot about that. Yeah. I guess the most interesting thing we saw otherwise was laptops.
Yeah, well, I was about to get to that. Yeah, the new Razer Blade 16, I think, is probably the highlight there. I think there are a couple major changes. The first one is that it's noticeably lighter and noticeably less thick. They said it has a 32% reduction in volume, which is very cool. They have a vapor chamber covering like 47% of the motherboard, so great percentage. And the other big change, well, they've made two big changes from a processor perspective, from a performance perspective. They've moved on to AMD CPUs.
Oh yeah, that's right. I almost forgot about that. Yeah,
which I think is probably a pretty positive sign when you're dealing with especially very thermally constrained, potentially very thermally constrained, at least as thermally constrained as a system that needs a hyper boost cooling pad could be. Certainly when you're dealing with those parameters, I think an AMD CPU makes a lot of sense nowadays. They have great efficiency, even up to the very high core count laptop parts that we do see in the market. The other change, of course, is Blackwell.
Yeah.
I get NVIDIA's Blackwell series GPUs up to the 5090 mobile, which is pretty impressive, wouldn't you say? Or at least potentially impressive.
Potentially impressive. We didn't see it running or anything like that. It was just like models to hold on to. Like I like held it.
Yeah.
That's really about it. I really held it.
Yeah, I do. Yeah, I do have a little bit of a slight bit of annoyance. And I remember when we had the 10 series back in 2016, where NVIDIA finally, they homogenized their laptop, basically homogenized their laptop and desktop GPU lines, had very, very similar models across both spectra.
It was impressive.
Slight differences in configuration sometimes, slight differences in clock speed sometimes, but broadly speaking, they were extremely similar, I would have to say. Whereas now we've kind of gotten to the point where basically the expectation is that like any kind of 5090 branded mobile product is not going to be especially close to the 5090 branded desktop product, which I do expect will probably be the case there. You also have these other designations like reduced TGP modes, max Q, things like this that get in the mix. Might be in the mix possibly with this ultra-thin Razer laptop, because I don't think you're getting a 125 watt GPU in there, at least not consistently, certainly. So yeah, there are some issues there, and I kind of frankly liked NVIDIA's old way of denoting their mobile GPUs, where they simply affixed an M to the end. That at least communicated something about the
That
relative
is somehow
performance
different.
level.
Yeah, I guess.
Yeah.
I agree with you there. But other than that, I would say not too much to say about it. It was just light, thin.
Yeah.
Screen was nice. Whatever.
Yeah. Certainly, it was a very, very cool looking device. But that wasn't the only OEM that we have to talk about today. There was also Asus, who had a few different technologies to show to us. Asus had a very interesting booth. They had a kind of deconstructed laptop for us to look at, which was pretty interesting, kind of like the different sandwich layers of the PCB, the different elements of the chassis, the plastics, the fans. Always fun to see the insides of a computer laid out like that.
Sure.
But I think the main point of interest here was actually some of the monitor displays they had running. In particular, Alex was rather taken by a Blurbusters demo,
Yeah.
but perhaps for the wrong reasons here.
Yeah, well, there's a couple other things. We'll talk about this a little bit later, as
Yeah.
I'll describe them as monitor sins or something like
Monitor
that.
sins.
This could be potentially considered monitor sins, where they had a demo of, I think it was an OLED on the left, and it was a G-Sync pulsar display on the right, running at both the same her level of refresh rate, if I recall, but obviously G-Sync pulsar is going to be HDR'd. It's going to be pulsing the display as well as being VRR capable. One thing is they had this Blurbusters display, but honestly, it was running not at native refresh rate. So you were getting like clear images, but then it was like constantly stuttering and showing double images as a result of that. So like, I'm pretty sure Mark from Blurbusters would have been pulling his hair out if he saw this demo next to each other. Even the OLED wasn't running as well too. So like, it was communicating that one was more clear than the other due to the pulsar and whatnot. Yeah. And it was like substantially clearer, but it was also running poorly. So like it just didn't look good. So kind of defeats the purpose of the demo if it's not running well. It's a little bit annoying actually.
Yeah.
So I just recommend if you're gonna set up booths like this, like really make sure that like it's actually running well.
Yeah, really make sure that those frames are very nicely, evenly paced, one for every refresh to really get that full Mark from Blurbusters experience that you're really looking for there. But they also had another monitor on display, which is more up my own personal alley, which is one of these 4K 240 hertz monitors. It's a 27-incher, which is just about the size that I am personally interested in for my productivity and gaming uses both on Mac and on Windows, honestly. But it was a bit of a disappointment, I'd have to say, just because it seemed like it was pretty dim, I'd have to say.
Yeah, it was pretty dim in that. I don't know if that was HDR on though. I have no idea.
I suspect it may not have been actually. I suspect it may not have been. In Horizon, it did look pretty dim. That's fairly typical for OLED monitors and SDR content. So that's a little bit unfortunate, but again, not unexpected with that display technology. Finally, there's one other one other firm that we probably should mention, which is Intel. They actually had rented out a good portion
It's like a floor almost.
of the Venetian Hotel, which is one of the sites for CES 2025. Not the main site, but these little booths were off to the side in this Venetian Hotel. They rented out a big space, but I don't think they really had big things to show necessarily. It was mostly focused on their new-ish GPUs. I think they revealed some mobile processors as well. They had some demos that showed off things that, for the most part, we could already see in the home.
Space.
Certain purchasing decisions. So to me, it was a big space. It was a big show, but it was not a big spectacle to me, at least.
No, and we walked in there. No offense to Intel, obviously, but we just also walked out pretty quickly because we were just like, we were on the move looking for other things, and this is all stuff we could either see at home or honestly read about to get most of that experience in there. So that's one problem with going to like conventions in general. Like you see this at Gamescom, you saw this back in the day at E3, as Rich has talked about before that. Like sometimes you can have a greater awareness and knowledge base by actually not going to one of these things. And the hands-on part actually has to be way more informative. And that's why you need reps there talking and describing things and actually showing you an experience that you just can't get at home.
Okay, so finally for this final section, we wanted to talk about some of the stuff we actually saw on the show floor of CES, the main show floor of CES, outside of the little secluded booths and outside of the Nvidia showcase demos. We actually did go to the show floor of the central hall at CES and visited the various automotive halls as well in different kinds of areas there. But we do have to disclaim this slightly with the fact that there was so much stuff at CES, and I only had 2 full days here. Alex had 3 full days here.
But not really.
It was not really. With jet lag factored in, probably somewhat less than that. You'd have to be realistic there. We did not have time to do a lot of private meetings or go to every single venue. I would have loved to have had more time here. So mostly we skipped most everything that had to do with fridges, trucks, or barbecues. Especially if they had a large language model component. I think
or a screen attached to them.
Or screens. Lots of large language models, lots of screens. Not so much interest from me and Alex, unfortunately, for those vendors. But we did try to sample some stuff that was of interest. And for us on the main show floor, that primarily revolved around displays, I think. So I kind of wanted to go display type by display type here, because I actually was quite taken, perhaps people not find this surprising, with some very bright displays that happen to be mini LED in nature. Basically displays with very many dimming zones, able to hit very high brightness levels, often based on VA panel technology or IPS panel technology there. And I saw some really impressive mini LED panels. I just think it's a great combination of really intense brightness, really deep, nice pitch blacks there as well as very large panel sizes without any kind of...
It's like 106 and 115 is like the biggest ones we saw.
Yeah, the number one standout mini LED TV for me was the TCL 115QM.
That's what it was.
891G, which is not a new TV. It's actually a 2024 model year TV, I found out. And I thought it looked absolutely amazing. It had very minimal backlight blooming, just incredible backlight control for a mini LED panel. It got incredibly bright, far brighter than you get from any kind of OLED panel, especially in very bright content where OLEDs tend to have aggressive ABL automatic backlight limiting. Yes. This did not have that issue. We also saw some Hisense TVs that did look impressive, somewhere in a similar range of size there. But I did find that TCL very impressive. The only downside, and I did not know this when I was looking at it on the show floor, but the price tag in the United States at least is $27,000. So
nope.
not not a very cheap TV, but what did you make of the various mini LED spectacle panels on display?
That was the best one.
Yeah.
I agreed with you on that. And I was also pretty happy with the black levels and the minimal blooming.
Yeah.
Obviously, like persistence is a different question in itself too, but that wasn't what the demo was about. That was being run. And the image quality was good too. We'll talk about image quality on other sets later.
Yeah.
These were good. I liked them quite a bit actually.
And there was also Sony was there. They weren't really showing off too many new TVs, at least that we saw, but they were showing off some LED panels running Lego Horizon Adventures on PlayStation 5. Very exciting stuff. They also had some Lego models on display, and they had a massive stage with some DJs and some poorly frame-paced content.
Yeah, some poorly that might have been AI gen stuff.
Something to do with
it was
AI.
some sort of, and it was pretty awkward, honestly. It was really weird, but whatever. These are some of these booth things that they do.
Yeah.
Some presentations and some kind of bad music.
Yeah, and Samsung also tried to pull some interesting stuff with like an art gallery themed.
Oh, that was maybe a bit more interesting, maybe.
Marginally more interesting, but not really a lot of interest there for me and Alex in terms of technologies. But there were a lot of micro LED televisions. Now, Alex, did we come away with a positive impression of micro LED televisions or a negative impression of micro LED televisions?
Pretty negative, actually.
Okay.
So I think the idea is like micro LED is hyped because we want to find something to maybe be a future replacement for OLED at some point.
Because
right?
it's like super bright, but also emissive. You get that perfect black levels. You get that great control, per pixel control.
Yeah.
That's the idea, at least.
Yeah, that's the idea. And these were all rather large sets, too. Don't forget that.
Very large.
Very large. So I guess you were getting like that good black and really high brightness. So something you would, like, it was these things that you wouldn't necessarily get on other panels. But, oh man, the image quality was bad. It was really bad on every single set, essentially. In some way, like one thing you would see is that you would see like that they're comprised of smaller like tiles.
Yeah.
And there was the tile lines were like incredibly obvious. So you had tile lines, and then you also had the space between pixels was really big, and you could see the RGB elements.
Yeah.
And they looked 1080p.
Yeah.
Didn't they look 1080p?
Yeah, there must be some quite significant. I mean, I can even make out the particular array of the RGB here. With the subpixel structure. But no, the dot pitch was not very good. They are made out of I think they're made out of these little kind of micro LED panels. And when you stick them together, you can totally see the seams. You can even see them sometimes from a reasonable distance. And the seams aren't totally uniform. Like some of them blend together pretty well.
And others don't.
Some of them don't look
It's like the manufacturing isn't consistent almost.
Yeah, it's not quite there. I have to say that the micro LED televisions disappointed me quite a bit.
I think I even said like, this sucks.
This sucks, yeah.
I was like, I couldn't imagine like buying this and having it in your house. They had like one that was ridiculously large. Yeah. And it was like so ugly. Like when you were near it, like you would have to be really far from this to like have enough blur in your vision to not see the issues.
The largest one they showed off was, I think, 163 inches.
Yeah.
Which is, I mean, you're seeing the footage here. It is an almost unfathomably large size television that you would have only, of course, you could always achieve extremely large panel sizes of a sort through projectors, but projector brightness and projector image characteristics are nothing like this, but also the image characteristics of these panels, I did not find them very favorable. We also saw some OLED panels in the show. Unfortunately, we did not get a chance to take a look at the new LGs, although I do understand the new LG televisions were at the show.
Yeah.
But there were some very interesting, actually from a few different vendors, but most prominently from LG, there were these 45-inch 800R curved Ultra Gear OLEDs that were set up with a certain racing game demo that perhaps you want to talk about a little bit, Alex.
This is Assetto Corsa.
It's Assetto Corsa Competizione.
Competizione. And these demos didn't, like, I thought the drive control, they were set up as like, like drive simulators, right? With like feedback
Force
feedback and like pedals and whatnot. So that was compelling, but I'm pretty sure these were like, they were high refresh rate, ultra wide OLEDs, and I'm pretty sure the game itself wasn't super impressive looking, unfortunately. So, and it also didn't look like HDR was on, was another issue. If even this game supports HDR, I do not know. And also it looked like VRR was not on and it was unlocked. Yeah. So it was just like jittery, right? Like it could have been a way better demo. And I just want to slightly tangent off into monitor sins. Can I talk about monitor sins?
Well, before we talk about monitor sins, I wanted to completely echo what you said about about this demo, because I think that Assetto Corsa Competizione, I actually did cover it on consoles back, 3 years ago now. I'm feeling a little old. I just turned 30, by the way, 2 days ago.
Don't tell them that.
So starting to feel my age, unfortunately, here. But yeah, Assetto Corsa Competizione, it's not a bad looking game, but it's also not the best looking racing title out there. I'd suggest personally something like F1 24 might be a really good PC demo with all those ray tracing technologies in there. Of course, one surefire way to have a good looking PC demo is to engage VRR. That is often a good decision there. They did not make that decision. I do believe this panel supports HDR. I don't think HDR was enabled. Perhaps it was, though, because it supports True Black 400.
So it could have just been low.
Which is a pretty low standard for HDR. I don't know exactly how bright it gets in HDR highlights, but possibly not very bright. Now, Alex actually did a pretty good job keeping things on track. I was not as lucky as you can see here. I ended up in the wall pretty quick.
I was taking it slow, though. I wasn't going so fast.
But that does move us on to some monitor sins, because there was another 45-inch OLED with a curve there, and it was running a certain other title. And there were some other instances perhaps around the show floor that maybe you can talk about.
Yeah.
Where we saw some extreme monitor and display sins, where basically people were showing off displays, some of them quite good displays. Some
like this one looked good actually on other technical levels, but they're just showing it off so wrong.
Showing it off incorrectly with content that's not right for the display, with certain features on the television that aren't flattering. So these were very nice panels in some instances, but they were let down by certain poor content choices, whether that came down to putting content on there in a manner where you're stretching it. That's a big no-no.
Like this one right here, it's GT7, right?
GT7, yeah.
Running, which is a 16:9 game, running on an ultra-wide. It also looked low-res for some reason. I have no idea why. Probably because it's the extreme stretching. It just did not look good. And also, this is more than a 60 hertz display. It was also running at 60 hertz.
Yeah.
Like, why? We also saw Spider-Man running at like 30 FPS with no motion blur in a recording that constantly dropped to like 15 and stuttered. And it was mirrored across 3 displays at once. Yeah. And it looked awful. And it was also stretched or whatever, I think. I don't know. And then we also saw Tekken being showed off, a game at 60 FPS. But it was also running motion interpolation. And so
it was
bad.
On LG C5, which is kind of their new lower end OLED this year. I think it's a 144 hertz panel.
Yeah.
So interpolated up to 144 hertz did not look very good. If it had just been run natively at 60, that would probably look pretty decent. But it was just a weird choice. It didn't
look good. We also saw another one we saw earlier. I think it might have been at the Asus display. Was also a 4K 240 hertz HDR panel that was locked to 1080p 60, and I changed it to 120 at 1080p. 120, and I was like, so they had a monitor there that was 4K 240, but was only running at 1080p 60. So like that was a common thing across the floor, and John's talked about this before, where you go to a place and they're running like games with like awful sharpening and tons of post-processing, not in game mode. And here, it wasn't just that. It was like wrong format, wrong color space, wrong whatever, wrong content. Really bad. Yeah. So if you're going to show off your stuff, please show it off at like the proper display, right?
Yeah, I mean, some of these displays, they're, high-end stuff, ultra-high refresh rates. That Ultra Gear we talked about is actually a 5K display, believe it or
right.
not. Yeah, over 5,000 horizontal pixels. Very, very impressive stuff in some respects at least. And they could certainly do a better job exhibiting that monitor and showing it off in its best light. Yeah.
For sure.
So I think that's going to just about do it for our CES discussion today. I think we had a lot of fun at the show, but I also think that there are some listeners who have a lot of questions.
Sure.
I have a lot of questions too. But unlike my questions, their questions can be answered.
Yeah.
So
Let's move on to that first question.
let's move on to that first question. So from a backer called From Another Richard, he asks, with DLSS 4 supporting older generation NVIDIA graphics chipsets, is it likely that we will see it supported on the Switch 2, and what benefits could it provide a device of that power grade given the hardware we expect to see?
I would say there's nothing technically impossible about that, considering DLSS 4 is ported backwards, but you have to think that Switch is not going to be focusing on running stuff that is heavier and looking better as a result. They're probably going to be focusing on greater performance as much as possible. And so I think if they're going to be running stuff on Switch 2 constantly, it'll be more akin to the older DLSS CNN model, which is going to be faster on older RTX like Ampere and whatnot, which this would be. And as we already saw before, as Rich has talked about, DLSS, if it was the standard model, would still, even in the older version, be very expensive on Switch.
Yeah.
So I don't think they're going to run something even more expensive.
I'd be very curious to see what like transformer model DLSS looks like on an RTX 2050 Max Q. Is that basically what Rich had demoed? Yeah.
That's right. Yeah.
Yeah, so that's a pretty intense scaling there from what it's intended to. I suspect the devices that it's going to be intended to run on for the most part. So yeah, I guess the real question for Nvidia, I think, and Nintendo there is actually, can they achieve a DLSS itself that's more lightweight, because the DLSS process on that kind of hardware just takes up so much time. It's not necessarily the quality of the DLSS that's in question. It's just 18 milliseconds for a 4K upscale.
Right.
You kind of can't do it. So even more time for a transformer-based 4K upscale, I kind of doubt it. Even if the input resolution could be lowered, it's not really the input resolution that's the issue necessarily in that case.
Right.
It's going to be the output resolution, which is what you see with upscalers, temporal upscalers in general. But we have another question about the Switch 2, Alex.
Yeah.
And it's a question that unfortunately we have to answer in the negative, which is, have you seen the 3D printed Switch Pro mockups floating around CES? What do you make of the supposed optical sensor in the Joy-Con, which is rumored to provide cursor functionality? Now, we did not see the 3D printed Switch Pro mockups. They were at the Genki booth, from what we understand. Genki being an accessories manufacturer that's infamous somewhat for having these mockups and flaunting their mockups, flouting Nintendo in their flaunting of their mockups. Very bold stuff, I have to say, from an accessory manufacturer. But we did not actually get the chance to see those accessories on the show floor. So yeah, I can't venture that we did. But in terms of that optical sensor, that's something that I can issue a bit of a more concrete guidance on, which is I do actually think it is providing some kind of cursor functionality. I do suspect that it may be, at least, just because of its positioning, because of the kind of the way that the Joy-Con fits in the hand, because of different kinds of pads that various people have uncovered in the Nintendo Switch shipping manifests that might indicate a surface for it that could be a mouse-like surface, a gliding kind of surface. Things like that, it does seem to me to possibly likely be for that purpose, or perhaps for another purpose, like as a heart rate sensor or a pulse oximeter. There are different kinds of uses you can get out of that kind of sensor there. Mm-hmm. So that could certainly be the case there. I don't know. Do you have anything to add, Alex?
Actually not. No.
Oh,
good coverage.
All right. Okay. From very professional Dodo. We all know DLSS is excellent as it is. But during the DLSS 4 presentation, there were several times where I wondered whether what I was seeing was real. not in a wow, this looks insane way, but more of a, I'm not entirely sure this is real detail or just a really convincing approximation of what it should be. For this reason, there is one test I would really like you guys to do when reviewing DLSS 4. Could you do a 16K natively rendered screenshot and then compare it against a 4K image using DLSS 4 performance? And if the two images happen to be quite different, do you personally believe that artist intent matters more than getting a good approximation, or rather, more than getting a good enough approximation of detail at improved frame rates? What do you make of this question, Alex?
I think it's an interesting one just because it is actually talking about something that I think is, what is the phrase? Like, I can't think of the phrase at this late hour, but basically there's a certain level of like impossibility that's being described here. And I feel like if we were to try and compare things to a 16K, what is approximate ground truth, we are actually not doing that because DLSS is not saying this is ground truth. I don't think that's trying to say that it is ground truth. It's trying to give us like a better approximation, a better quality for our subjective senses. And you have to go into that with a certain level of like subjective description. And if you start comparing to a 16K ground truth, which could produce interesting comparison, it's not something we've done ever before for any other thing ever. And it's actually holding it up to a mirror that is a little ridiculous. Like we've never done that before. No one's ever done that for anything really before, other than for technical papers when trying to describe their approach, like their simplification approach versus ground truth. And it's more like figuring out what you can try and do in the same frame time budget. That's more interesting.
Yeah.
I always feel like from the user perspective. It could be enlightening to a degree, but it's also almost impossible to capture because do you capture it with TAA? No, you shouldn't then. No, because it's another approximation. So you would have to capture it raw and then raw with no AA and then downsample it, or like I tried to do this for my TAA video to show the way things look, and even then it was a bit wishy-washy. I think the idea is kind of interesting, but I think it's also kind of missing the point of image reconstruction as a real-time application.
Yeah, that's always important to consider when people start banding about like CG and stuff like this, or like the incredibly detailed kinds of light interactions that you can get with like an offline path tracer working for hours and hours and very complex imagery. Getting that kind of stuff in games requires different kinds of approaches because you're never going to get that level of per frame 16K fidelity in this case. In a game, I mean, 16K is an insane amount of pixels. So you need to be somewhat realistic and understand that approaches that work for offline are not necessarily appropriate for real time, and even 16K is an absurdity for offline, so perhaps we should just leave it at that.
Yeah, we should be really concerned about like perceptual rendering.
Exactly.
More than perfect rendering.
Yeah. So on the topic of high-end PC technologies and potential exciting PC approaches to rendering here, we have this question from some guy person. It seems like Nvidia is trying to create their own branch of all key UE5 features with RTX kit technologies. RTX Mega Geometry equals nanite.
No.
No? Okay. It doesn't. Yeah, Alex is just saying no.
It's not the same thing, but it's an addition to it. Almost. Yeah.
Well, perhaps you can get to that once we finish Mr. Some Guy Person's question. RTX GI equals Lumen. RTX character rendering equals metahumans. The list goes on and on. Why would a developer use these features over the Unreal implementations? Would a developer just have these RTX APIs as options to replace the UE5 feature set, or would someone build a game centered around these technologies?
I mean, I think just to answer the latter first, some people could build the games around these technologies in some ways. Like I can imagine the Witcher people doing it, like CDPR. And I think they could do things like that, like they've done in the past to a certain degree. That's where they feel like that's the way the game should look. but that's going to be a much more rare thing. And I do think Nvidia is offering a little of like semi-competition to Epic themselves by doing these kind of things. And I imagine Epic would maybe see it that as way too, but they're also trying to, at the same time, push people to use their technologies in the most widely used engine across the market. But also the things that they're adding here are not exactly replacements for UE5 features. They are additions and or side things that make them better in a certain way. Like Mega Geometry is saying, okay, now you can actually run like full res geometry while doing ray tracing, which Lumen doesn't do. So it's not the same thing, you know what I mean? And RTX GI here is actually talking about like full ray tracing, which is not the same as Lumen, which is a simplification, you know, a greater simplification. It's also a simplification too. And then the character stuff is once again, like it's plugging into things that are going to go maybe further in some direction.
Right.
So I don't see it like, I see it both as like internal competition, but it's also like Epic can only push things so far. They have to target consoles, right? So,
yeah. Being able to be lifted from those console constraints is what gave us incredible efforts like the first Crisis. And I feel like with the incredible spend of modern game development, that isn't really something that's entirely feasible.
Yeah, most people don't do it anymore. So
for most games outside of that, I hate to go back to it, but Black State is a PC first title, although they'll have to find some kind of accommodations for consoles if they choose to go down that console route.
Oh, for sure.
Yeah. So let's move on to a question from Salmon. Salmon, not Salmon.
Yeah. Salmon.
Hello. How do you think multi-frame gen is going to work in games with frame pacing? From Soft-like, I think he means the lack of frame pacing or incorrect frame pacing. Or animation, Silent Hill 2, Star Wars, etc. Jitter issues.
All right. Well, I'm going to quote Rich, garbage in, garbage out. It'll be it'll be better in some ways in terms of like the average experience maybe, but it will still, if the game stutters, it'll still stutter. If a game still has animation issues, it'll still have animation issues. And in fact, it could be almost more potentially distracting because the base frame time might be quite a bit lower, the fluidity might be higher, and then all of a sudden it's more jarring as a result because it stands out a bit more. So I don't think it actually helps these games at all in the traditional sense.
Yeah, that's too bad. That's too bad. I mean, it can help certainly in some titles where there's like a severe CPU limitation that can certainly help.
That's a thing. Yeah, for sure. Yeah, but like, you know, that requires frame capping and, you know.
It requires some finesse.
It requires some finesse and a lot more. But also we shouldn't aim to fix games that have animation or stutter issues with frame gen.
No, it's not the right approach.
Not the right approach.
I agree. But on the topic of frame pacing, or at least frame pacing of a sort, we have this question from Zephyr. Hi, DF team. Given multi-frame generation and the larger embrace of dynamic res on PC, will VRR be obsolete in the near future? Interesting. Seems like the dream of running every game at your monitor's maximum refresh rate could actually come true now. Alex, with MFG, with DLSS 4, are we going to see a future where I can play every game at 1,000 hertz?
Eventually, yeah. I think that's the nth degree goal at this point. Maybe not with Blackwell, but with whatever comes next or the one thereafter, which could add in like an 8x mode. I'm just spitballing here. I have no idea.
Alex is spoiling.
Yeah, but like the whole point is like no one is ever going to actually, for any reasonable game, target something like 1,000 FPS. It would have to start looking like Quake level, and it'd have to even be very optimized, right? Yeah. I don't think that's a reasonable target for any game with great visual ambitions. So we got to find out other ways to achieve that level of smoothness and also that level of low persistence. Mm-hmm. And frame generation is one of the ways to get there. And I think the nth degree goal would be like a free floating internal frame rate that runs at any like multiples that is then frame gened up dynamically to your end output refresh rate. And it would be like slightly below VSync to get reflex benefits at that point. So I think that's the really nth degree goal there.
Yeah, I think in the long term, the idea of eliminating VRR in favor of a completely fixed refresh enabled by MFG of some extremely high-end variety, I have to imagine. Mm-hmm. does sound very interesting to me, but in the short term, I'm much more interested about giving my 4K 240 hertz display for my 5090 because nothing else will really saturate that thing. That's the thing.
Yeah, you definitely need the display first.
You need a crazy
expensive.
display.
Yeah, it's super expensive. So let's not worry too much about that right now.
Yeah. But well, on the topic of people who might be worried.
Oh yeah, good one.
Yeah. Do you think? Trying with my transitions here as a one-time DF Direct host. Do you think Mark Cerny? This is a question from Andre Surles. Do you think Mark Cerny is kicking himself with the AMD choice and having to fix the image quality themselves? How will AMD compete in the next generation? Well, I think this is an interesting question because of the way that it's framed, because we know that AMD has their own image solution, or possibly their own image solution with their little project that they showed us, or that we got showed ourselves, I suppose. Mm-hmm. So they have their own solution. It seems like Sony has their own solution. But do you think that Mark Cerny is kicking himself, Alex?
I feel like the graphics industry is kicking themselves because, and so we talked with other journalists, a bunch, like 50 people, like independently. We were talking with everyone. We were just meeting everyone, and I was talking with a ton of people, so many people.
Lots of people coming up for pictures, saying hi.
It was very cool. It was really nice. But like the general sentiment is when you looked around those demo booths that we were walking around, and also the Jensen Huang presentation, like it was just so overwhelming with the depth and breadth and width and detail and the amount of software features in general, and the advancement of them and the rapidity of the advancement, that it was ridiculously overwhelming. Nothing like I've ever seen before. And Nvidia feels 5 years ahead of everyone else at this point. AMD is potentially going to be getting their ML upscaler at some point in the nearest future if this research project ends up being it. But then they have to get to real ray reconstruction added in games. They have to get to ML frame gen. They have to get to multi-frame gen. They have to show off neural materials. They have to show off equivalent of Mega Geometry in a real setting, running at real time, being accelerated. They have to show off. Oh my God, like I can keep going on with this list of things where it's like the software package of Nvidia is just making this seem ridiculous on a lot of ways. I don't know what to say about it. It's weird.
It's a tricky thing, and I've been thinking about this quite a lot, and especially in the wake of the Blackwell announcement. It's like Nvidia is like its own platform where they're doing all these like really intense, crazy things.
Oh my gosh.
That you don't see on the competition, or if you do see it on the competition, it takes years. Like we had DLSS 2 in 2019?
DLSS 2 was like the beginning of 2020, I think.
2020, okay.
Or maybe it was at the end of 2019 with that one title. It's like a space title. It's like something the moon. What's it called?
Deliver Us the Moon?
Yeah, I think it was Deliver Us the Moon was the first title.
Yeah, and then some. We're looking at 5 years later. We're looking at possibly the implementation of a similar machine learning-based upscaler, although a very high-quality one, apparently, at least in
from our first impression.
Our very first impression with our finest off-screen footage available. Certainly, it does seem like NVIDIA is kind of a platform unto themselves, and it's built on Windows, but it's almost as much NVIDIA's as it is Microsoft's at this point. And then you have, your other PC vendors who are doing their own things. Then you have the consoles that are doing their own things. Then you have the Switch 2, which is sort of an interesting little box. I wonder exactly which bucket it will fall closer to. I suspect because of how low power the hardware is, it probably will not be approaching the heights of some of that NVIDIA hardware, but obviously it is NVIDIA powered. But I mean, is Mark kicking himself? I don't think so. I don't think so, because you know what? PlayStation is a huge brand, and they went with AMD for the PS4. I think that was the correct decision at the time. I think it was a decision that made a lot of sense because they could get a high-performance SoC with a nice big GPU, Pitcairn. A Pitcairn rivaling GPU in that system. Netbook class, but still like decent enough for console purposes CPU. And for PS5, they were able to extend that generational lead that they had in PS4 with a design that had very, very good backwards compatibility, and that's continued with PS5 Pro. Those are elements that other vendors probably could not guarantee or could not produce, flat out could not produce. And that's extremely important for Sony. I think the question for Microsoft is a little bit more interesting because they are not as wedded possibly to that AMD box because, they've not done terribly well. Their fortunes are not possibly as wedded to the past as it would be into the future. So I guess it'll be interesting to see what Microsoft's next approach takes, if it will be more of an AMD approach, if it will be more of a cross-vendor approach. Who knows? They're dealing with different kinds of priorities there. But bit of a left turn here, away from the doom and gloom and Nvidia of it all, onto a question about a game that we reviewed last year and took a look at several times, which is Final Fantasy VII Rebirth. Abhi asks, what do you think of the Final Fantasy VII Rebirth PC specs? So what do you make of those PC specs, Alex?
I've called them up right here, right now on my phone. I think the interesting thing about them is kind of a specific thing that we saw most recently in Star Wars. No, sorry. Wait a minute. My brain. Oh, yeah. Alan Wake 2. Sorry. As we get later and later here. Alan Wake 2. We're basically, if you look at the minimum requirements, it's requiring an RTX GPU or an RX 6000 minimum, so RDNA 2 GPU on the PC. And that is the most interesting aspect of the specs right there. And I think that's calling back to the fact that the game is going to require mesh shading.
Right.
They mentioned somewhere that it's using primitive shaders.
They mentioned it in the PlayStation blog, I believe, back when the game launched on PlayStation 5.
I mean, they say they're using it, but honestly, you look at those LODs and the geometry in the game,
doesn't show it.
You'd be hard pressed. But it could be there, obviously. And if they're trying to mimic that on PC, you can't do it on Pascal, and you definitely can't do it on RDNA 1. There's no explicit support for it, so it's going to require RDNA 2 and above, or RTX and above. So I think that's the most interesting thing. Mesh shaders are supported though by the GTX 1660 though. I'm pretty sure, right?
Yeah.
They just don't have RT cores and ML. So
stripped back turn.
Yeah, so maybe those will work, but that they were not listed under the specs. Interestingly.
Okay, that's interesting.
Yeah.
I think that PC port, certainly there's some interest there. Maybe we can take a look at that when it does come out during a rather busy time for PC gaming in general and certain high-profile PC releases. But they've improved the lighting to some degree, improved the shadowing, things like this in the cutscenes. Perhaps not the most pressing area where that game needed some revision, but certainly it'll be interesting to see how that compares perhaps to the existing PlayStation 5 Pro version, and if it is indeed a good PC port or something more in line with its predecessor. Which,
oh God, I hope not.
Which I took a look
at. I would
at
skewer them
3 years ago with your assistance, and that was quite a messy port in a lot of respects. Okay, all right. One final question here, and it's a bit of a fun one because we've had a fun time here, but we've also had a slightly tiring time as I sit here. It's something like 1 a.m. in the morning, unfortunately for us.
I'm leaving in like 6 hours.
Late in. Alex is leaving in 6 hours. I've got a flight to catch too, although not nearly as long of a flight to catch, thankfully.
Yeah.
But Johnny_5A asks the question, hope you are having fun stateside. What's the most out there, but I love it thing you've seen on the floor so far? So I hope you're having fun stateside, Alex. Are you having fun stateside?
No. I'm not going to lie. I think Las Vegas is pretty awful. I'm not a fan of this city, either in layout or many of the other things I've seen here. But CES as itself, I think I've loved meeting other journalists. I've loved seeing people, I saw like NX Gamer here, I saw Andreas Schitting, I saw Ian Cuttress, saw Steve, talked with Tim from Hardware Unboxed, talked with him for a while, which was a lot of fun. So many other people, and I've really gotten to know them and thought they're really good people, and as well as everyone I saw and talked with at Nvidia too, and all the people I also talked with at AMD that were really nice to me.
Yes.
So there was, and just being stopped on the floor, and people want to say hi, that we watch your stuff, we like you. So I've really liked that experience, but I've thought like this area and the way I move around it hasn't been great.
Yeah, I'd have to concur. One of our recurring issues here at, at the hotel we're staying at is that every time you go down to the lobby, every time you go down to the bottom floor, there's this massive casino, and the way that the floors are designed, it's very kind of designed to always push you through the casino, and the signs are labeled in such a way, almost Kafkaesque. You can't tell where anything is at any given time. You disorient yourself very quickly. We've been here basically for 3 days now. Every time we go down, we have to go down in pairs, or else we'll get lost here, because every single thing that is here is basically designed to make you waste money on the casinos. So that's quite a dark thing, really.
Yeah, it's been like, and also just like walking the street and like trying to get anywhere. Everything requires like car transport.
Yeah,
it's rough. It's like, it's coming from a city with incredible, for my standards, public transport, and you know, I would consider Berlin really walkable, and also the price of things. It's so different. It's just radically different than my normal life in ways that I don't always approve of, but that's personal preference, obviously. So, but I've liked CES from like that perspective. But the other part of the question, what's the most out there but I love it thing you've seen at the floor so far? I think we saw the fan display demo.
That was cool.
That was weird and cool. Really got these spinning fans that display stuff, almost hologram-esque. You can't see it on the footage that Oliver did, because like you can actually see the fans due to shutter speed and stuff like that.
I tried a bunch of settings, but I couldn't quite get it to not do
the
that.
guy recommended like 24 FPS, and it's like, I'm not setting my camera to 24 FPS.
Yeah, it's kind of cool though. You get these images that appear to display out of nothing because the fans that have those lights are painting those images effectively are moving so quickly that all you really notice is a bit of a breeze and a buzz in the air and these crazy light shows, which I think are quite compelling in person. Again, not so much in this footage, but Alex spent quite a while having a chat.
Yeah, guy was excited to talk to us.
Excited to talk to us.
Yeah. But yeah, that was a funny one, and you know, obviously we didn't check out the self-driving tractors or anything like that, but that would probably floored us.
No. Well, maybe next year. Unfortunately, this time around we found that we had a very, very compressed schedule, so we saw as much of CES as we could. We did not see as much of Vegas as we could, that's for sure.
No.
But perhaps we did not have a very strong interest in seeing much of Vegas.
Probably not. Yeah.
So on that note, we have to bid adieu to DF Direct Weekly for this week, for the second week of 2025, the year of our Lord 2025. As always, I would advise you to check out the Digital Foundry Patreon at digitalfoundry.net for exclusive and early access content. Check out the Digital Foundry store, which is full of our merchandising wares, very pleasing stuff. For any kinds of further inquiries, or if you have a question, or if you just want to bother us, check us out on social media. And Alex,
what do you say?
Auf Wiedersehen.